Okay, this is a video where I'm going to try to resolve the circular reference with a function. Now, it's going to be a pain. The first thing I'll do is resave the file, and I'll call it a function. Okay, and let's talk about philosophy, and the reason we're doing this first, and that is that when we change something, I just did that at the end of the last video, put some new variable here, we'd have to redo this, and it would crunch around, and it would start, in my opinion, to limit the flexibility of the model. So, if we're going to use a function, we need to kind of find this variable, and then we also need to find these two variables. Okay. How we can do that is to go to the bottom and start with perhaps this one, and then start with these ones, and then work backwards. And when we work backwards, we'll essentially work through the whole damn model, both to the down and to the side. Okay, and if it was only one project, it wouldn't be all that difficult. It would still be a pain. But with two projects, it's going to be a real pain because we need to adjust for the net income we're earning, because this net income will affect the equity balance, and the equity of balance affects this debt to capital, which is how I decided, at least, to compute the ultimate thing we want to compute, which is how much equity we need to put in the project. Okay? So what we do is we go to the developer tab, and we can go to macro. We can just edit any of them. Now, how about this? For once, we could perhaps go up to the top. Now, whenever you do this whole thing, I would suggest first putting option base 1. That just, it's a pain that you have to even bother doing that, but that means any arrays you're going to use will start with the number 1 rather than with the number 0. Okay, and then let's define a function, and we can find cost or something, and we'll do that. Now, when we are going to have a function, we'll make it as a variant, and what that will do is it will allow us to put 3 things out. So then we'll put a dimension. How about we'll call it output, just because I've been calling it output in other things. And I will put 3 outputs. Okay, and then at the very end of the function, we'll put find cost equals outputs. So that's the first painful kind of thing. Now, so let's say I put outputs somewhere here. Outputs 1 equals 1, and then we can copy that. So let's put output 2 equals 2 and output 3 equals 3. Okay, and then we select this and put equal. What did I name it? I named it project cost or something. Total cost. Well, that's really great. I can't remember what I named it. How silly. Okay. Find cost. Is that what I named it? And what we can do is, what if I put sub find costs like that? Then we can remember to see where it is. Okay. Shift Control 1, and it didn't work. Great. Okay, we have to make it sideways. I just learned that. Okay. That's enough. That's getting us started. Now I'm going to pause. The next step in getting this function started is, we're going to need a whole lot of inputs. Unfortunately, we're going to need things like the input for the total cost of the project 1, the cost of the project 2. If we want the income, I think we need the operating income on both projects. I'm not going to bother with the exit proceeds. We're going to need the dates. The dates, and I think we're going to need a little thing that says, well, over what period do we want this to be computed? And what I want to do is just be able to click on a line like this, because we'll have all our horrible inputs. So I'm going to put model period. And let me see. Just a minute. This is horrible. Oh, here's this construction period 2. This, anytime we have a true, we want it in. Once we have a false, we don't want it. So what we could put is, we want everything. Let's put or. Okay, now if I do that, just trying something, I've never really tried this before, then these are all the periods. So we'll take all of these periods with true. Now I'm going to cheat a minute, and because I've done this a few times, we're going to make a little thing that will allow us to read variables where we put the whole thing in like this without having to select the whole thing and press F4 and all this. And what we'll do is just kind of work backwards once we do this. So I'm pausing for a minute. Okay, so what I did was I put in the function library. Let me see. So if you go to chapter number 1, Excel Utilities, there's a function library, and in that function library, one of the functions I inserted was circular references. the function. Now in this model, there's a resolution of a circular reference. It's seeming to take a long time now. My machine has computer has started to go really slowly. And we'll go to the macros and we'll look at one of these. Now, this one, you can see what I did is I worked through, I read in a period, and if the period was a number, we just got the beginning and the end. That's all I'm gonna say. So let's do the same thing. So we need the start period and the end period. So I'm gonna copy this, get rid of this whole thing, go back to our macro. Okay, and the next thing we'll do in our macro is to read in a period. Now this period will be how about I'll just start with 1. That's, if this is true, then take this plus 1, otherwise, let's leave it as a false. Now, I don't know what happens when no, shit. It didn't, it put a 0 in there. So, oh. Now, I don't know what it does if you put is number. That's a false. So it just will, it will go until we just hit a false there. Okay? So we go back to our macro, and we go around, and we say, okay, let's go around period. And we can get a start period and an end period. And the good news for that is we don't have to go around forever. Okay? That's as easy as that is. Okay? So we've kind of set up this. Now the only other thing we have to do is to start finding the cost. So this might be total cost. Now the total cost, if we go down here, we can start looking at what the total cost is. The cost of project 1 and the cost of project 2. Okay. Okay, those, I didn't say anything while I was typing that, so project 1 cost will be one of the outputs, and if you spell it wrong, you're going to have a big problem. Some people like to dimension all the variables. I'm not sure which takes longer, making guess it's a trade-off between how many spelling mistakes you're going to make and how long it'll take you to put them all in. Okay, now let's start going back, and project 1 cost equals the project 1 construction. Okay, I'll just uh, okay, so okay, and now we need to define this con str1. We can put in both of these things. Okay. Okay. And then now we can make four start period to end period for I equals start period to end period. Next time. Okay, and you could say, oh no, we better turn off our cost at the beginning then, you know, and perhaps we should do that. Okay. Okay. And let's try this. So even though we've done almost nothing, let's just make sure that we've kind of got it going. So I think down here, well, we put it 0. So we put equal find cost, and we can just start by putting the period in, and then we can put in the construction construction expenditure for project 1, and then project cost for period 2, and then we press shift control enter, and we get our kind of our total project cost and our project cost for 1 and 2, which is good. Okay, and you know what we could do then is eventually this fixed cost will be the total project cost, and these two costs will be these two costs. So we start at the end. So, you know, and that's pretty good news, really, because now we just have to start working backwards. Okay. Now the problem here, and the reason we have a circular reference, is we need the IDC for both of these. So I'll call this IDC1, and this is going to be IDC2. And now our problem's going to be magnified. Now the IDC1 is going to be project cost 2. Well, that was kind of stupid. See, wasn't it? Okay, project cost 1 times the debt to capital ratio times the interest rate. Okay. Now, Okay, and project cost 2, IDC 2. So this is the opening, excuse me, opening balance of the balance. And now we also need to subtract. So we stop taking the in this, we put in service. How about project 1 in service? And then we'll have to do the same thing for the second one. CRVIC. Hope I did everything. Now we have to figure out when it goes in service. So eventually the project in service is and you know, I should have well just a minute. I'm thinking. I've got to pause it for a minute. Okay, so I'm gonna go. I think the style of this video will be that I go back and forth. I type a few lines in and then I explain. So we have the IDC, that's a function of the interest rate now, and the debt to capital. What we need to do is read in the interest rate, that means. Okay, so we'll just kind of go one by one. And then the project cost includes the IDC. The IDC, I do not believe it has to be kept in a separate array because it's just a function of the project cost. And I have to be a little bit careful. This is the project construction work in progress. Construction work in progress. Progress is better. Sorry. And then we need the in-service period for 1 and 2. How about instead of, I call this as the occupancy date. O date 1. So we have O date 2. Okay. So we need to read in comma O date 1 and O date 2. Now, right now, interest that with debt to capital is 0, so IDC 1 is 0, IDC 2 is 0. We can look at the period. Now, the period right now is going to be redefined as this period. Okay, because that's a number. And we stick the in-service date in as the project cost, and then this construction work in progress eventually goes away. And I think we still don't have any divide by zeros or circular reference problems. So we're going to try to do this thing again. And this shift F3 if we want to find. So this period we can just, maybe I should have called it the start date, but I'll leave it as the period for now. And then we can just look at our construction for 1 right? Construction for 2. And now let's look at our assumptions, and we need the interest rate. Okay. And then we need the first date for the project 1, and then we need the date for construction 2. Now when you do this, it gives you some numbers. This is good news. When it gives you no numbers down here, it means you're going to have a value. So far, we're still okay. Okay? Now, what we need to do next is go back and define the debt to capital. Now, the debt to capital will be the, this is going to be a really pain. To cap equals the opening debt divided by the opening debt plus opening equity. Okay, now we better, whenever we do this, put an if, open debt. Why don't I put I'm going to just define a total capital. Okay. And we can put down here if total capital is not equal to 0, then we do this. Now, that means we have to find the total debt, the opening debt and the opening equity. And the, which is fine up here, but down here, by the time we get to the end, okay, opening debt equals opening debt for the, this is for the next period, plus the debt issued minus the debt repaid. And that means we're going to have to go through this whole analysis here and to go to the, we're going to need to get the total cash flow first, okay, and then the equity funded, and we're going to do the same thing for the equity. So we need the opening equity equals the opening equity plus the equity issued plus the net income minus the dividends. Okay, and now to get this, we need to first get the, why don't we get the operating cash flows? And the operating cash is equal to the project 1, how about PO1 cash plus PR2 cash. Now, and then we put minus CONSTR1I minus CONSTR2I, and we have to be very careful and realize that these we're reading as in an array. So we can now we could put PR1 cache, comma PR2 cache. Okay. Okay, and there, now we have this kind of thing, and I guess I'm gonna just continue. So the net cache equals the operating cache minus the interest plus minus the fees. Now, what I'm going to focus right now is on the interest, and the interest is equal to the opening debt times the interest rate. Okay, and that's what we're focusing on. And now we have to go to the equity funding. This is going to be a really tricky one. Equity funded equals remaining funding remaining funding, and we put the minimum of the remaining funding or the net cash. And we only do that when we have to kind of put a minus here. And then we also have to make sure that this only occurs at maximum minus. Okay, and then I'm gonna pause for just a minute. Now, when we compute this remaining equity, remember, I don't know, I had to do this where I had to say, well, after we've used up all our equity at the beginning, eventually this equity goes up because of the net income way after we've built everything. So and we should never have a negative equity. So so what we should do down here is when we have our remaining funding, well, maybe I'll try to compute it here. So the remaining funding, I did this wrong too. Okay, equals equity commitment. Okay. minus the opening equity. Okay, and this should be the minus of the net cash of 0, and this should have been the remaining funding. I wonder if, certainly if you're smarter than me, you can do this, but you know, eventually you can almost say it's in a way easier to do some of this programming with equations than it is to type it all into Excel. The Excel it's just the way to present it. You should understand these formulas, I think. And we said, well, we never want this to be negative, so we put worksheet function dot maximum, and we take this one and put comma 0. Okay, so we've got the first part finished, and then the problem is this is the equity issued. Okay, not funded. Okay, now the equity commitment is down here. Is equal to the total cost times the equity percent. So we need to, and I hope I put the total cost the same, and that equals the up here, the equity percent. So we've got a few more variables, and we've done some of this, and I think we should try again. I'll just okay, we still I redid the find cost, and I'll keep doing that, and I think it makes sense to go very slowly like this, to just start at the way back, and what was I gonna start at the way back and just keep trying at different stages to make sure you don't screw something up. Now, the problem here is the opening debt is we have a couple of problems. First, this total cost, we're going to have to put a iteration around it. I'm going to, whenever I do this, for the first round, put for iteration equals 1 to 10 or something. We really don't have to start worrying about the fancy kind of convergence algorithms and all that. Okay. And I'm maybe grouping a couple of these. You don't want a waste of time to have you watch this. Okay, so now let's put the next kind of subtotals in. So after we put the equity issued in, we can say that something like that. Cash to debt is equal to net cash plus the equity issued. And then we can put the, I'll leave it. We can put the debt funded equals, here let's just put debt so where's this is debt issued minus debt repaid. Did I call it debt issued? I called it debt funded, so I'll call it debt issued. And this is when we have to issue it when the worksheet function maximum is the minus cash to debt or 0, and we will issue as much as we want. There's no limit on that one. And when we repaid it, we put worksheet function dot maximum, and we put this time the cash to debt or 0, but we make sure that this is worksheet function worksheet. See, that would have screwed everything up. Dot minimum of this or the opening debt. And I shouldn't sound a little bit hopeful, but we're sort of getting a little bit there. Dividends equals cash to debt minus debt issued plus debt repaid. Okay, now if we go down, we still have to compute the net income. I think we've got just about everything else finished. To compute the net income, unfortunately, it's an incredible pain because we got to get the depreciation for both kind of projects. So and I think we're just computing the capital, so we say how about project 1 depreciation equals one in service times the depreciation rate 1. How about I'll put DEP rate 1. And then we can do it the second one. Okay. This project 2 in service times depreciation rate 2. Okay, so one piece of slight good news about doing all this is that we review the formulas pretty carefully. Depreciate 1, 2, okay? And we're going to get the net income now. So we've got kind of this thing that we didn't need. We've got the debt to capital changing, and that's for the same thing. We've got the equip balance, the plant balance. I'm not going to worry about all this retirement shit. We've got the second project. We've got the total interest, I hope. We have to divide it by 12. I forgot to do that. And we have the net revenues already. We have to subtract the depreciation. The gain on the sale, that will happen so far afterwards, after we're finished. Unless we, sell one before we're finished the other. So I'm not going to worry about that one right now. And then we've got the debt and the equity. Okay, so I hope you don't mind that I'm trying to stop at a reasonable period here. So the net income, we've got the where's the where did I put the income? Project 1 cash plus project 2 cash. So we can we have the net income equals the project 1 cash plus the project 2 cash minus the project 1 depreciation minus the project 2 depreciation. Okay, and we've got everything defined now, and we better remember to get the depreciation rate. Oh, I did that. Now what I should do is interest rate. Well, we better do this. Don't really have to, but it's probably better for him to do it down there. Alright, divided by 12. I'm going to do the same thing with the 1 equals G 1 divided by 12. Okay, so now I'm going to stop the video. I'm going to try it again. We should have most of it finished now. So the good news is it didn't take an absurd amount of time. The bad news is by the time I keep testing it and seeing if it works, it might take a little longer. Now the other thing I'm going to do is switch the fees off so we don't have any fees. We'll do this without fees. Okay?